So today we're going to look at a couple different friction problems. The first one we're going to look at is using applied force, have a block accelerating, and then trying to figure out the coefficient of friction. So here we have a 30 kilogram block sitting on some rough surface. There's going to be a force applied. It's going to be equal to 114 newtons. And the block is going to accelerate at 1.8 meters per second to the right. So we're going to have to figure out a mu from that. In order to find mu, we're going to have to find frictional force and normal force. So the first thing we're going to want to look at is the sum of forces statements for the x and y direction. We'll look at the y direction first. Sum of forces y should be equal to 0 because the block is not going to accelerate into the air or down through the surface. And those forces should be weight minus normal, so that in fact normal force is equal to weight. In that case should be then 30 times 9.8, which gives me a value of 294. And then I can come back over here and substitute that 294 newtons in for normal force. Now the only thing I have to do is figure out friction. And the friction force I'm going to figure out and realize is going to be involved in that parallel to the motion of direction of motion. So I'm going to have to look at that sum of forces statement in the x, which should be equal to ma. And those forces should be force applied minus friction. So that friction is equal to force applied minus ma. So then friction should be equal to 114 newtons my force applied minus 30 times 1.8, and that gives me 60 newtons for friction. So once I realize that, then I put my 60 newtons over my 294 and I get 0.204 as a coefficient of friction. So it's just one of those problems where we look at F net, right? We use the fact that we know it's accelerating and we know the applied force, so we find friction rather than having applied force and friction and just finding acceleration of the object. We use that acceleration to then go ahead and find friction, and that allows us to calculate for mu. In another situation that we might have, we're going to look at objects, or an object that has a force applied to it that's not parallel to the ground, and how that's going to affect normal force as well as coefficient of friction, etc. So here I'm going to have a 40 kilogram block with an applied force of 90 newtons at 25 degrees above the horizon. So if I look at a free body diagram of that situation, right, I have weight down, I have normal force up, there's going to be some friction, and we're going to know in this case that our coefficient of friction is 0.2. And that should be the ratio of friction to normal force. So in this case, we're going to look at trying to figure out the acceleration of the block. We have that force that is got some upward components. So our free body diagram looks like that. We want to make a little analysis diagram so we can isolate those components. And then once again look at sum of forces statements to figure out how those forces are going to apply. So the x component of my force should be cosine 25 times 90. And the y component of my force should be sine 25 times 90. And those values should be 38 for Fy and 81.6 for Fx. So once again, when I go ahead and try and then resolve my forces, trying to find coefficient or find acceleration, I can find frictional force that's going to be involved in this particular situation by the fact that I know mu. So if I look at sum of forces in the x direction, they should be equal to ma, and those forces should be the x component minus friction. So now I have 40 times a equals fx, which is cosine 25 times 90, minus mu times normal. And I can come back to that in just a minute once I figure those out, those values, and solve that. For my normal force, sum of forces y should be equal to 0 once again, because even though I'm pulling up, unless I'm pulling up with a huge amount of force, right, the object's not going to fly into the air. It's going to be dragged along the surface. So I'm going to have F sum of forces y equals 0, and those forces should be normal plus that y component of tension that is up minus the weight. So that weight minus Fy should be equal to normal. The weight should be mg. Fy should be sine 25 times 90. All that should equal normal force. My mg should be 392 minus my 38 for my y component of tension, and that should give me 354 for normal force. So now I can go back here and say that A should be equal to cosine 25 times 90, which is my 81.6, minus 0.2 mu times 354 for normal. All that divided by 40 should give me A. And my acceleration in this case should then be equal to 0.27 meters per second per second. So that's going to allow me then to look at the fact that the y component of tension makes normal force less, which gives me less frictional force than if I had straight 392, I'd be, like 78.4 newtons of frictional force rather than 70.8. And I guess the next logical question to look at would be, would it accelerate, or how would it accelerate if it were going the opposite direction? If the force applied were downward, in this case, I'm going to give it a 100 Newton force down at 25 degrees because I don't think the other one's going to work. And here I'll still have weight, I'll have normal force, I'll have some friction. Right? And by the same token, I'll have my Fx, my Fy will be down, my weight will be down, my normal will be up, and I'll still have that frictional force. So looking at those F components should be cosine and sine of 25. Should be 42.2 newtons Y. And 90.6 newtons in the X. My weight should still be 40 times 9.8, which is still 392. So I could look at sum of forces Y equals 0, and they should be equal to normal minus weight minus Fy. So weight plus Fy should equal normal, and those should be 392 plus 42.2. Should be 434.2. So now my sum of forces Y, X, should equal MA. And those forces should be Fx minus friction. So I have 40A should be equal to 90.6, which was cosine 25 times 100, minus friction, which is mu normal. So A equals 90.6 minus 0.2 times 434. And A should be all that over 40. So A should be 90.6 minus 86.8, which is 3.76 newtons all over 40. Gives me an acceleration of 0.094 meters per second. So you see how, had I stayed with 90 newtons, I'd only had 81.6 and I have to be like 86, so I wouldn't have been able to move it. Had I stayed with just 90 newtons initially down, my applied force in the next direction, this would not have been enough to counteract friction, so the object would not have moved. So I have to apply a little bit more force downward, obviously, because the normal force, when I'm applying a downward force, is going to be equal to whatever the weight is plus that y component. So I have to be careful of that. And you could end up, like I said, with a situation where you'd apply one force up and it would move, and the same force at a downward angle, even if it was the same downward angle, and it would not move. So there's just 3 different examples of problems where you might look at, and this one being one of the more relevant ones, where we look at forces that are going to be applied not necessarily parallel to the direction of motion.